So in the previous class, we discussed about tracking radar, so which used sequential loading and conical scan modulation. And there, the disadvantages of conical scan modulation was it requires more than one pulse to process the information and to detect the angular error and also range. So these disadvantages, okay, so where due to multiple pulses are necessary for processing and to maintain the amplitude, okay, so will be minimized. So if we select only single pulse, so here in this class, okay, we are going to discuss about monopulse, monopulse, okay, so monopulse is signal, okay, so where we have taken single pulse for processing, okay, so in both single coordinate and two coordinates. So here only one pulse, okay, so only one pulse is necessary for processing and extracting the range information as well as angular error. So that is why it is known as monopulse, okay. So here, unlike in sequential loading and conical modulation, so we are going to use more than one lobe, okay. So that is why we have to add the other word which is known as simultaneous lobing. So here, along with the monopulse, okay, so monopulse echo, receive echo signal, okay, so for the consideration of processing and to extract the range and phase detection, okay. So here we are using more than one lobes simultaneously. So here monopulse tracking radar, okay, so uses only single pulse for processing, and single pulse is enough for extracting the range information as well as angular error. So pulse to pulse amplitude fluctuations of the echo signal have no effect on tracking accuracy if the angular measurement is made on the basis of one pulse rather than many pulses. So this is the main advantage of monopulse tracking radar. So here we are using only single pulse, okay. So we are going to transmit single pulse and the receive echo signal contains single pulse. So single pulse, single carrier frequency, okay, is enough, okay, to process the received echo signal and to separate the carrier, okay, carrier high frequency carrier signal from the received echo signal, and then at the receiver, okay, so the demodulation is done, that means separation of the carrier and low frequency signal, okay, which is obtaining from the moving target uh, is determined, okay. So all these things, okay, can be done by using single pulse, okay, rather than using many pulses, unlike in sequential loading and conical scan modulation. So the range and angular error is also determined by using single pulse. So hence all these amplitude fluctuations of echo signal will be eliminated. So when we consider only single pulse. So more than one antenna beam is also used simultaneously in these methods. So in sequential logging or conical scan modulation, only single antenna being used. Okay. So for searching for the targets. So whereas here more than one antenna beam is used. That is why it is also employing the technique called simultaneous loading. So the angle arrival of the echo signal may be determined by measuring the relative phase or relative amplitude of the echo pulse received in each beam. Okay. So here we are going to transmit, okay, so signal from the transmitter. So whenever um, before it is transmitting, so we are going to use two horn antennas, okay, so which generates two radio frequency signals, okay, so which are combined with the reflector antenna, okay, so and single beam, okay, so from the two horn antennas, okay, we are going to generate two antenna patterns, okay, two antenna beams, okay. so simultaneously. So when they strike, okay, whenever the transmitter signal transmits, okay, so by using these two antenna beams, okay, so at the reception in the receiver, okay, so we just receive the echo signal, okay, so which contains some one difference of the two antenna beams, okay, which we have transmitted, okay. So here the relative amplitude or the relative phase of the received echo signal is detected, okay, for the error, okay, for the angle error. So in this technique, okay, so in this lecture we are going to discuss about the technique where we are going to compare the relative amplitudes of the echo pulses received at the receiver section. And in the next session we will see how the phase is detected, okay, for detection of angular error. So there are two methods to describe this type of tracking technique. They are simultaneous lobing and monopulse. So simultaneous lobing in the sense we are going to use more than one lobe, okay, so more than one antenna beam, and since we are considering single antenna, okay, single pulse for processing at the receiver, so it is known as monopulse. So in this technique, the RF signal which is received from two offset antenna beams are combined so that both the sum and difference signals are obtained simultaneously. So as we discussed, okay, so radio frequency signals which are received from two antennas, okay, two horn antennas that are connected at the parabolic antenna reflector, okay, so are combined. So they are combined in one magic key antenna or hybrid section, okay, which contains four port signal, okay. So through two ports, so we are going to send two antenna beams, okay, two RF signals, okay, which are able to generate two antenna beams, okay. So here at the third and fourth wavefront, okay, so it is going to give the two outputs which are nothing but the sum of the two antenna beams and difference of the two antenna beams, so simultaneously. So the sum and the different signals are multiplied in a phase sensitive detector to obtain the both magnitude and the direction of the error signal. So here the sum and different signals, okay, at the receiver are multiplied in a phase detector, okay. So here the phase sensitive detector provides the phase angle error information. So it offers us the both magnitude and direction. That means the sign of the error signal also. So according to the sign of the error signal, okay. So the antenna beam, okay. So the reflector antenna is adjusted such that to minimize that error signal. So since the technique we are using here amplitude comparison, okay, so that is why it is known amplitude comparison monopulse, okay, because here we are going to study the variation of amplitude, okay, so based on which the range information can be taken. So the amplitude comparison monopulse implies two overlapping antenna patterns to obtain angular error in one coordinate. So this amplitude comparison can be extended in two coordinates also. So here first we are going to discuss about in one coordinate, that is one polar coordinate, okay, and we will extend this concept to two coordinates where both azimuth and elevation errors can be detected. So here first we are going to discuss in single coordinate. So here we are going to use two overlapping antenna patterns, okay, so which are obtained from two feed horn antennas. So the two overlapping antenna beams may be generated with a single reflector along with two adjacent feed horns. So single parabolic reflector, okay, which is of the shape parabola is used as the main antenna, okay. So along with the two adjacent feed horn antennas are connected, okay, so that these adjacent feed antennas generate radio frequencies, okay, so they fed it to the single reflector parabolic antenna, so where it can be combined and transmitted from the transmitter, okay. So the sum pattern is used for transmission. Okay, so we here after combining, okay, after combining these two in hybrid junction, okay, so two patterns are available for us. So one is sum pattern and another one is difference pattern. So here we are going to uh, transmit only sum pattern, while both the sum pattern and difference pattern are used on reception. Okay, so at the receiver, so we are going to use this difference and sum pattern for comparing the amplitudes as well as for comparing the phase of the received echo signal. So the signal received with the difference pattern provides the magnitude of the angular error. So whenever the echo pulse is received along with the difference pattern, okay, so which is available at the receiver. So when they are compared in the phase detector, okay, the magnitude of the angular error is generated. So the sum signal is used for the range measurement, okay. So along with the transmission, so the sum signal, okay, so in the sum channel is act as reference to compare the amplitudes of the transmitted and echo signal, okay. So whenever they undergo comparison, so the amplitude detector detects the amplitude variation in the echo signal, okay, so received echo signal as well as which is available in the sum channel. So and used as a reference to extract the sign of the error signal. So here it is, it helps us to provide the sign, okay, so whether it is negative or positive signal. So signals received from the sum and the difference patterns are amplified separately and combined with phase sensitive detector to produce the error signal. So whenever the echo signal is received, okay, so they are separately amplified in IF amplifier. So the function of IF intermediate frequency amplifier is to bring down, okay, so their frequencies into a moderate value, okay, so into intermediate frequency value. So these frequencies should be lower than the transmitted radio signal and must be higher than the or equal to the received, okay, so the desired signal, okay, whose frequency should be in the range of video or audio signal at the receiver, which is nothing but the desired signal from the moving targets, which is of low frequency signal. So here we have a block diagram of amplitude comparison monopulse tracking radar for a single angular coordinate. So here we are going to determine only one error signal. Why? Because here we are operating only on in single coordinate. Okay, one coordinate. Okay, so this is the block diagram. So which comprises of a transmitter. Okay, at the transmitter section, so we have some channel, okay, so which is used as a reference, and as well as duplexer is used normally, okay, so to transmit and to receive the signals at a time, okay. So from the transmitter, when the signal is transmitted, okay, so at the parabola antenna, so here we have antenna feeds, okay, so these two antenna feeds. So before transmission from the transmitter, these two antenna feeds, okay, on antenna feeds generate two radio frequency signals, okay. So which are able to provide two antenna beams, okay. So these are combined in hybrid, okay, magic key junction, okay. So here this hybrid junction is able to uh, produce sum and difference of the two antenna signals, okay, two antenna patterns, okay. So here the sum pattern is used, okay, so for the transmission. So whereas the difference, okay, so is used to extract the, okay, difference channel, okay. So at the bottom is used as the reference channel to compare, okay, the phase uh, shift of the received echo pulse and the difference pattern. Okay, so here when the sum is generated, it can be transmitted using the transmitted antenna. So okay, available in the duplexer. Okay, whenever the receiver, okay, so after the transmission, the transmitted pulse is propagated in the space, and whenever it strikes the moving target, so it sends an echo. Okay, so the received, so it generates an echo. So the received echo signal is received at the receiver antenna, which is present in the duplexer. So here this received echo signal, okay, so can be processed further. So in the mixer available in the both channels of sum and as well as difference. So okay, so here in the sum channel, the echo signal can be processed to determine the range of the signal. So whereas in the difference channel, it is processed, it is compared with the difference pattern to produce the angle error. Okay, okay, angle error tells us in what way the antenna should be moved, okay, to face the direction of the target. Okay, so here when the received echo signal is given to the mixer, okay, so a reference signal from local oscillator is generated. So here the echo signal in the sum channel is combined with the local oscillator signal. Okay, so to separate, okay, so to maintain the phase shift as it is, okay, in the echo, receive echo signal. So here this mixer, okay, provides the required echo signal. Okay, so by eliminating the unwanted amplitude fluctuations, and that signal is given to the intermediate frequency amplifier. So where the received echo signal's frequency is brought down to the intermediate frequency. That means this frequency should be lower than the radio frequency signal, but higher or equal to the desired video signal for further range processing. Okay, so and in the difference channel, so that received echo signal is mixed with okay, is mixed with the difference pattern. Okay, so here again the phase shift is maintained constantly, so with the help of local oscillator. So by eliminating the unwanted phase shifts, okay, so the local oscillator acts as coherent oscillator, okay, to maintain the phase shift. Okay, so phase shift same in the both difference pattern and as well as in the received echo signal. So here the mixture generates the sum and difference of the uh, transmitted and received echo signal. Okay, so where carrier can be eliminated. Okay, the high frequency carrier can be eliminated, and only the signal of our interest, okay, which is the low frequency, okay, audio or video signal is can be transmitted. Okay, so this IF amplifier maintains the frequency of the received echo signal, and this is combined in the okay both signals, okay, from the sum channel and difference channel can be combined in phase sensitive detector. So where those two sum pattern and as well as difference pattern are multiplied, okay, so to generate, okay, the angular error signal. Okay, so which is nothing but the error signal, okay, so by which the direction of the antenna should be forced towards the direction of the target. Okay, whereas in the sum channel, the remaining the amplitude detector, okay, helps to produce uh, to detect the envelope of the received echo signal. Okay, so such that it maintains the amplitude clearly, so and it is able to track the range of the target clearly. So the two adjacent antenna feeds are connected to the two arms of a hybrid junction, such as the magic key, a rat race, or a short slot coupler. So any of these hybrid junctions can be used, okay, to generate sum and difference patterns of the antenna. So the sum and difference signals appear at the two other arms of the hybrid. Since hybrid junction contains 4 ports, so 2 ports are used for giving inputs, okay, so in the form of radio frequency signals, okay, so where we can get the sum and difference patterns of the antenna beams. So on reception, the outputs of the sum arm and the difference arm are each heterodyne to an intermediate frequency and amplified. So in the receiver, okay, so the receiver has to demodulate the signal, okay, that means he has to separate the carrier from the low frequency video signal, okay. So this can be done at the mixer, okay, so which is a part of super heterodyne receiver, and then it is amplified, okay, so the desired frequency signal, okay, so is amplified and its frequency is brought to intermediate frequency range. And the output of the phase sensitive detector, okay, is an error signal whose magnitude is proportional to angular error and whose sign is proportional to the direction. So here the outputs of the outputs which are available in the sum and difference channel are given to the phase sensitive detector, where it is multiplied, okay, and the magnitude of the angular error is generated, means how much value by how much quantity the error lies, okay, and by how much quantity the antenna should be moved such that to make to arrange the antenna axis and target axis same, okay, and to reduce the error, okay, and the sign is proportional to the direction, that means in which direction it has to face can also be determined by using the angular error signal. So the angular error signal actually it activates the servo control system to position the antenna. So on the range output from the sum channel feeds into an automatic range tracking unit. So here, and as we discussed earlier, so whenever there is error signal, so that error signal is given to the servo control mechanism, so where the motors are available, okay, so those motor adjust the position of the antenna such that it has to face the direction of the target. And in the sum channel, okay, the range output from the sum channel feeds to automatic range tracking unit. So the work of amplitude detector, okay, so is to extract the envelope, that means the envelope of the received signal, okay, after demodulation, okay, so and to detect continuously how far, okay, the signal, the target lies from the antenna. So the sign of the different signal may be measured by determining whether the different signal is in phase with the sum or 180° out of phase. So actually the operation of low coherent oscillator is to maintain the phase shift constant. Okay. So here, if in case while at the receiver, if there is a chance of phase difference, okay, so then the channels, okay, because the sum and difference are two channels we have. So if in case there is a phase difference in the two signals, okay, so it can determine, okay, it is measured with the help of the sign variation, okay, so whether the sign variation is positive or negative. So if it is positive, the both channels, okay, the outputs from both sum and different channels are in same phase. So if they are out of phase, okay, so the sign will be negative. And coming to the outputs generated in single coordinate, so here we have the left-hand diagrams, okay. So all the left-hand diagrams are the beams, okay, antenna beams, which are extracted in single coordinate, okay. So here the first figure A, okay, the left hand side figure represents the two antenna beams, okay, generated from two feed antennas, okay, horn antennas. And in the figure B, okay, at the bottom left hand side figure represents the sum of the two antenna beams, and whereas in the figure C, okay, so in single coordinate it represents the difference of the antenna beams. And coming to the D, okay, the figure D shows the error signal voltage. So the steeper the slope, okay, the minimum the error value. So, and coming to the right hand sided figures. So first figure, it represents the two overlapping patterns in two coordinates, okay, in x and y plane. And bottom, the right hand side figure represents the sum of the two overlapping patterns, whereas the third figure represents the difference of two antenna beams, okay, so in two coordinates. And here, so till now we discussed the angular error, okay, so in single coordinate, and we have shown two coordinates also. So how it is done in two coordinates, let us discuss. So this is a block diagram of amplitude comparison monopulse tracking data for two angular coordinates. Okay, so that is, here we are going to measure elevation and azimuth angles simultaneously. So for that, what do we need to have are? So we need 4 feed antennas now. Okay, so as it is able to generate 4 overlapping patterns now. So from them we are going to obtain 2, okay, from 4 overlapping patterns we are going to obtain, so 2 sum, okay, so all are able to generate the sum of the signals. Okay, so here we are going to use some channel. Okay, so sum of the two channels, we are going to use sum of okay, sum of the two feed antennas together as one output, and another sum of the two overlapping patterns as another output. So from using these two, okay, so we are going to extract difference channel by subtracting the sum from two adjacent antennas from the sum of the another adjacent antennas. So similarly, the difference pattern is available, okay, by subtracting the difference patterns available from it. So that is why we have here 4 magic junctions, okay, to produce the sum and difference for two planes. Okay, so here, as we mentioned earlier, sum channel, okay, sum is used for transmission, whereas on the reception we are going to use both sum and difference channels. Okay, so that is why we have 3 mixers. Okay, so to maintain the phase constant in 3 channels, so here we have 3 types of mixers. Okay, so to eliminate carriers and to extract the desired signals, so we need 3 mixers, and local oscillator is provided to all mixers to maintain the phase value, okay, constant among T channels. Okay, and T IF amplifiers are used, okay, to bring down the desired echo signal from targets, okay, into a intermediate frequency, and two phase detectors are used to generate 2 error signals. Okay, so one is for elevation signal and another for azimuth signal, and one amplitude detector is used to detect the amplitude variation, okay, for comparison, and to track the range of moving target at the time. Okay, so here we need one extra thing, that is nothing but the automatic gain control. Why? Because here we are operating on 3 channels. So that is why to eliminate any kind of voltage fluctuations and to maintain the receiver gain constant, okay, so we need the action of automatic gain control. So the cluster of 4 feeds generates 4 partial overlapping antenna beams here. So these feeds are mostly used with the parabolic reflector or cascade antenna. So same parabolic antenna is used as the main antenna. Along with that, four horn antennas are connected to it to generate the four different overlapping antenna beams. So all those four feeds generate the sum pattern. So all those are able to generate the sum pattern. So the difference pattern in one plane. Okay. So here we have two planes. So one is for elevation angle difference and another for azimuth angle variation. So here the first difference pattern in one plane is formed by taking the sum of two adjacent feeds, okay, and subtracting this from the sum of the other two adjacent feeds. Okay. So we are going to add two overlapping antenna patterns once and the other two antenna patterns separately. So here we are going to subtract one from another. So in this way we are going to generate one difference pattern. And the difference pattern in orthogonal means in perpendicular plane means in another coordinate is obtained by adding the differences of the orthogonal adjacent phase. So here what do we have? Since we have four overlapping patterns, okay, so all those are able to produce sum and difference. Okay, so in one plane we are going to subtract the sum values, okay, to generate the one difference pattern, and here we are going to add the difference patterns, okay, so available from those four overlapping antennas. That means from two overlapping patterns we are going to get one difference, and from the other two overlapping patterns we are going to get another difference. So here in another, okay, in perpendicular plane, so we are going to add these two differences such that it can provide the another difference pattern for another difference channel. A total of four hybrid junctions generate the sum channel, the azimuth difference channel, and the elevation difference channel. Okay, these three separate mixers and IF amplifiers are required, one for each channel. Okay, so to separate carrier frequencies, to maintain the phase shift, to maintain intermediate frequency for each channel, we need three separate mixers along with three separate IF amplifiers. So all three mixers operate from a single local oscillator in order to maintain the phase relationship among the three different channels. So two phase sensitive detectors extract the angular error information, one for azimuth and the other for elevation. Okay, so as we have shown in the block diagram, okay, so here two different channels are available here, okay, so which operate to determine elevation angle error and azimuth angle error. So this can be done by using two different phase sensitive detector. Okay, so where the sum pattern is combined with the difference pattern in one plane, and to detect the elevation angle error, and the sum pattern is combined, that means the sum pattern is multiplied with the difference pattern available in orthogonal plane. Okay, so to generate the azimuth angle error. So here two orthogonal planes, in the sense they lie in two different coordinates. Okay. And the range information is extracted from the output of the sum channel after amplitude detection. So here if we see in the sum channel, okay, so in the first channel, so the amplitude detector detects the envelope of the received signal, okay, so by separating carrier signal from the received echo signal, so it detects the amplitude, okay, and gives the low frequency signal, okay, so which is to be passed through the video amplifier for the range measurement. for the range measurement, and here the range is has to be tracked correctly. So this can be done by using automatic gain control. Okay, so here the range tracker separately tracks the range of P, means how far it lies, and it eliminates the further amplitude fluctuations. So that is why the feedback is necessary, okay, to suppress any kind of unwanted fluctuations in the received echo signal. Hope you understand. So in the next class we are going to discuss and phase comparison monopulse tracking radar. Thank you.